C. So A is what's in front of x squared, B is what's in front of x, and C is our constant. Now, we're going to learn what I call quick factoring. So we're going to want to do this if our A value is 1. Now to do this, it's way easy, it's way quick, but you can really only use it if the A value is positive 1. That is a rule you got to remember. So, this is how we would quick factor. Now this is always how we start out factoring all quadratics, whether we're doing quick or long factoring. So everybody, we pick out our A, B, and C values. So A is 1, B is negative 3, and C is negative 10. Do we see where I'm getting that? A, B, C. So how we always start this out is we do what multiplies to be A times C and adds up to be B. So we're going to first start out by multiplying our A value to our C value. So 1 times negative 10 is negative 10. And then B will insert right in, which is negative 3. So now what we're going to do is we're going to list out factors of 10. Now when I say factors, I mean what multiplies to be 10. So 1 times 10, 2 times 5, and then that's it, right, everyone? Now we want two of those factors to be able to be added up if we put a negative on one of them to be negative 3. Or we can put negatives on two of them, or no negatives. So looking at this, we need it to add up to be negative 3. Would 1 and 10 ever add up to be negative 3? No matter what, no. How about 2 and 5? Yes. Which one would the negative be with? 5. Now look, we would say, okay, so 2 plus negative 5. We ought to check. You have to make sure it works in both boxes, because sometimes it'll work over here, but not over here. So check. Does positive 2 times negative 5 equal negative 10? Yes. And then does positive 2 plus negative 5 equal negative 3? Yes. So it works in both boxes. So those are what our factors are. So everybody, because our A value is positive 1, we can do quote, quick factor. So what we do is we just make our parentheses. You put the variable in front, x and x. And because we can quick factor, we literally just insert those right in and sign and all. So it's positive 2, so we'll do plus 2, and then it's negative 5, so we'll do minus 5. And we're done. Now let's say on the test you're like, did I do it right? We'll multiply it back together and combine like terms, and you should end up back there. That's quick factoring. Let's do another one like that. Okay, so you'd say, okay, it's a quadratic. Now, guys, understand this is how we factor quadratics only. So what multiplies to be A times C? Look, A is 1. What multiplies to be A times C and adds up to be B? So A times C is 12. My B value is positive 8. So now we're listing out factors of 12. 1 times 12. 2 times 6, 3 times 4, and that's it. So which ones could add up to be 8? 1 and 12, no. 3 and 4, no. 2 and 6, yes. And then 2 plus 6 does equal 8. 2 times 6 does equal positive 12. So those are our factors. You would check, can I quick factor? Yes, because our leading term is positive 1. So we throw in our parentheses, x and x. Then insert those right in. So positive 2 and positive 6. Easy stuff, right? Okay, another one. Let's go quicker though. So what multiplies to be A times C? What multiplies to be 1 times 18 and adds up to be B, which is 9. Let's just see if you can tell me the factors without listing them all out. So what is it? 3 times 6, 3 plus 6. Make sure it works in both. Check and check. Then I can quick factor because my leading term is 1. So that would be y, sorry, that's a weird y plus 3, and then y plus 6, and we're done. All right, looking at this one, let's do this one. What multiplies to be A times C? What multiplies to be 24 and adds up to be 14? 2 and 12. Let's say you didn't know. You just list them all out, right? 1, 2, 3, 4. So 2 times 12. 2 plus 12, so this factors to be P plus 2, P plus 12. And then you make a good point. It only works if it's positive 1. It has to be positive. Okay, I think we get the picture, but I do want to point out something between these two problems. Once people see how to factor a quadratic, they freak out when they get to something like this. But it's because they're forgetting. Before you factor anything by any method, you should be factoring out a greatest common factor. So look at the top. This would not be factoring a quadratic. This would be factoring a greatest common factor out. What's the greatest common factor? So we'll pull out an x, divide by x, divide by x. Left is x plus 3. Quadratics should have 2 linear factors. 1, 2. Don't we have 2? All quadratics will have 2 factors because it's degree 2. Okay, now looking at this one. Let's do it. So everyone notice this is actually this. X squared plus 0x's minus 49. So when we do what multiplies to be a times c, it's 1 times negative 49. What multiplies to be negative 49 and adds up to be 0. The middle term 0. 7 and 7, and one of them would need to be negative. Negative 7 plus 7. It works over here. That's negative 49, and that's 0. So then we can quick factor because our leading term is 1. So this factors to be x minus 7 and x plus 7. Are we good with that? Okay, awesome. Okay, looking at this one, guess what people do? They just start doing what multiplies to be a times c. Wrong. That's how we factor quadratics. This is cubic. What should I factor from the beginning? Greatest common factor, which is 3u. Okay, good. Now divide by 3u. What is with my pen today? We're already having my new pen go bad. Divide by 3u. So then left would be u squared minus 3u minus 40. That's a 7. Minus 40. Now you'd say, okay, I've factored one thing out, but I got to see if the inside continues to factor. So now you look inside and say, oh, this is a quadratic. So I would do what multiplies to be a times c, what multiplies to be negative 40 and adds up to be negative 3. Good, 8 times 5, and it would need to be negative 8 to add up to be negative 3. Negative 8 plus 5. Once again, I am so annoyed. This is a brand new pen, and it's because I write too hard. Honestly, it's my own fault. All right, check, check. Can we quick factor? Yes, so we have a 3u, and then this part factored to be u minus 8 and u plus 5. Wow. U minus 8 and u plus 5, everybody. So don't forget. I'm so freaking mad. You have no idea right now.
Let's just take a nap. This is the world telling us, hey, John need a nap.
And 5. Okay, everyone. Do not forget the original 3u that you factored out. Now look, degree 3 should have 1, 2, 3 factors. Do we see? Awesome. Okay, I think we get the picture here. Now, what if it does not have a positive 1? Then we have to do what's called long factoring. Those of you, you need to write this down. Like, you need to write this down. So, long factoring takes much longer, but it's not too much worse than what we've already done. It's like an extra 2 steps. So, if it does not have a positive 1, you cannot just insert them right in. That's really bad. If you do that, you'll get the wrong answer. So instead, you have to say, okay, we do start out the same way, however, as factoring all quadratics. So we always do what multiplies to be a times c and adds up to be b. That's always how we start out. So everybody looking at this one, there's no greatest common factor. So I would factor the quadratic by doing what multiplies to be a times c. So 3 times 8 is 24, everybody. Let's insert that in. And then our b is 14. Now we need to figure out what factors multiply to be 24 and add up to be 14. 12 times 2. All right, now check, it works in both cases. Now because we have a 3, we cannot just insert and go x plus 12 and x plus 2. So we're at the step called drop and break. Drop and break. So what we do is we drop down our end terms exactly as we see them. Drop and drop. So that's positive 8. You guys see how I've just rewritten them exactly as you see them. Drop, and then we're breaking down the middle term. So we're rewriting 14x as, well, let me show you. Ding, 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 ding. Look at, do you see how that's a 14? X. And we're writing it as these two things, but with an x. Do you guys see how it's related? So 12x and 2x, order does not matter. I can put 2x first or I can put 12x first. It really doesn't matter. So it's both, they're both plus, so plus 12x plus 2x. And now we have 4 terms, and now we're just factoring by grouping. Like we learned in the first bit. So we grouped the first 2. The second 2. The greatest thing in common here is a 3x. So divide by 3x, divide by 3x, left is x plus 4. Pull out the greatest thing in common here, which is positive 2. Divide by 2, divide by 2. Left is x plus 4. Sorry about that, x plus 4. Now here's the thing, guys. If you get to this point and this isn't the same inside, you've picked the wrong factors or you've just messed up somewhere. Okay, so I pull out x plus 4. So then it divides out, leaving me with 3x plus 2. And we're done. I know for those of you that have had me that was like, okay, you went so grandma slow, but for everybody else that probably felt a little fast. So just people that have had me before, be patient. Okay, let's do another one like that. So let's factor. There's no greatest common factor, so we're going to do what multiplies to be a times c and adds up to be b. 12 times negative 6 is negative 72. And then our b value is negative 1. What 2 things multiply to be 72 that could add up to be 1? So 1 times 72 are factors of 72. What else? 9 and 8. Isn't that the 1? So which one would be negative? 9, because it needs to add up to be negative 1. I don't know what it's doing. Negative 9 plus 8. So now you'd say I cannot quick factor because the leading term's not 1. So I drop. So drop down 12x squared. Drop down negative 6. Exactly as you see that. And then you're breaking down the middle term. Now remember, where is that related to? Right there. But with an x. So insert those in, and order doesn't matter. So minus 9x plus 8x. That's a 6. And then we'll factor by grouping. Greatest thing in common here is a 3x. Divide by 3x, divide by 3x. So then left is 4x minus 3. Wow, this pen is really having issues, isn't it? Pull out a positive 2. I'm literally going to go ham sandwich on this pen in about 5 seconds. Okay, so 4x minus 3. It's the same, so we've done it right. So pull out 4x. I'm not even going to teach anymore. I'm literally just going to throw this pen. Okay, well then have fun learning 4 lessons next time. So pull out 4x minus 3. This is ridiculous. I know exactly what it is. The pen's getting worn down in a weird way, so it's like not recognizing my touch screen. Okay, so we pull out 4x minus 3. Wow, this is not okay. And then left is 3x plus 2. We get the picture. Okay, do you want another long factoring one? Well, do we need another long one? Are you sure, everybody? Okay. All right, sounds good. Okay, now looking at this one is different than what we've seen before. So we have 24x squared plus 13xy minus 2y squared. Now it is quadratic. There is no greatest common factor. The only difference is there's now y's involved. So what you're going to do, everybody, is you're going to pretend like the y's are not there. You're going to go, okay, so we have a 24x squared. We're going to keep the x's. So x squared plus 13x, and then we're going to say minus 2. Pretend like the y's aren't there. Do you guys see how we know how to do this? We know how to factor this. So let's do that. What multiplies to be a times c? What multiplies to be negative 48 and adds up to be 13. Let's say you don't know. Do 1 times 48, 2 times whatever, 3 times whatever, 4 times. Do you guys see what I'm saying? So what are the factors? 9 and 4? 5 and 8. So you're saying that adds up to be 13. 5 and 8 is 40, so you're saying it's actually 6 and 8. Yeah? Okay. Okay, cool. So now, which one would need to be negative? It won't work? Okay, so what factors? It's not that it doesn't factor, we just don't have the factors. So keep going. No, but it was a good thought. 16 and 3. You guys see how it's not worth skipping around? You literally just should have listed out 1, 2, 3, and you would find it. So I'm just trying to prove a point here. It's almost, if you don't know right away, just start listing them out in order instead of jumping all over the place. Because I have a lot of people say, this one won't factor, and I'm like, let's go in order. And it's like 4, and they just didn't think about it. So everybody, just list them out if you need to. So you drop and break. So we have a 24x squared, and we have a minus 2. We're breaking down that middle term as these two factors. You said 16 and it's a minus 3x. So I'm going to go ahead and put the 16 first, and let's just make sure we're good. So 16 minus 3x. So factoring by grouping, pulling out the greatest thing in common here, which would be 4x. It is 8. So 8x. Good catch. Divide by 8x. Divide by 8x. So then left is 3x plus 2. Pull out the greatest thing in common here. Negative 1. I'm having a rough day. Really. This makes me so freaking mad. Alright. Pull out a negative 1. Then left is 3x plus 2. So we'll pull out our 3x plus 2. Divides out. And left is 8x minus 1. Now, what about the y's? Look at the end. We have a y squared, don't we? So wouldn't it be smart to put a y here and a y here? Because a y times y would be y squared, everybody. So now I'll just say, but there was y's, so I put a y and I put a y. There's y squared, right? And then look at the middle term. So the middle term will be 3x times 8x is 24x squared. 3x times negative 1y will be negative 3xy's. And then 2y's times 8x would be 16xy's. You guys see how that makes the middle term an xy? And then the ending term, we need it to be negative 2y squared, and it is. So we just treat it like a quadratic, like normal, and then insert your y's in the end. Yeah. Okay, good. Awesome. So I think we get the picture. I don't need to do another one. Okay. Sweet. Okay. We're almost done here. One more method. Actually, let's have you go practice a few quadratics before we move on. So far we've learned how learned how to factor by factoring out the greatest common factor. That's always what we look for first. Then second, if you have 4 terms, factoring by grouping. And then third, if you have a quadratic, factoring by long or short quick factoring. Now when you look at something like this, x to the 4th minus 2x squared minus 24. It looks very similar to this. X squared minus 2x minus 24, doesn't it? Because look, it goes 2, 1, constant. Over here it goes 4, 2, constant. Do you guys see how they look almost identical? So we can actually factor this with kind of manipulating it. So it's called a U-substitution. Now here's why. We can rewrite all of these x's with x squared. So x to the 4th is the same thing as x squared squared, isn't it? Raise a power to a power and you multiply. You guys see what I'm saying? Then we have minus 2, and then I'm just going to put it in parentheses. We have an x squared, and then we have minus 24. Now look at your equation. It has all x squareds in it. So what we can do is now go off to the side, and we can make a U substitution. So we're going to say, let u be equal to x squared. Now wherever there's an x squared in our equation, we're going to replace it with a u. So right here becomes u and a u. So now our new equation is u squared minus 2u minus 24. And now look at that. It's a quadratic that we know how to factor. So let's continue factoring this. So we would say what multiplies to be a times c, what multiplies to be negative 24 and adds up to be negative 2. So that would be 8 times 6, not 8 times 6. That's not 24, that's 48. So 24, and adds up to be 2. 6 times 4, and it would be negative 6, wouldn't it? Negative 6 plus 4, it works in this and this box. Then you'd say, can I quick factor? Yes, my leading coefficient's 1, so this would factor to be u minus 6 and u plus 4. We've just factored the quadratic. Now what you're going to notice is we weren't dealing with u's to begin with, we were dealing with x squared. So we've now got to take and put back in what we substituted. So those were actually x squareds. So x squared minus 6 is actually what we're looking at, and x squared plus 4. Now we're done as long as the quadratics inside do not factor anymore. We better check though. So that would be our answer unless the quadratic factors more. So let's check this one. What multiplies to be a times c? What multiplies to be negative 6 and adds up to be 0? Anything? No, so the quadratic does not factor. Okay, let's look here. What multiplies to be a times c and adds up to be 0? Because b is 0. 2 times 2, 1 times 4. Anything? No, so we are done. But there are times when it would continue factoring. So factoring with the U-substitution, it's called being quadratic in form, because it was quadratic in form. Okay, let's do another one. So we have 2z to the 4th minus z squared minus 15. So you're going to have to recognize in the future, because I'm not going to say on the test, factor by a U-substitution. You're going to have to recognize. Degree 4, degree 2, constant. You guys see? That is quadratic in form. We're going to use a U-substitution. So this is really 2z squared squared minus z squared minus 15. So now we're going to say, let u be equal to any x squared. So now we have 2u squared minus u minus 15. Now we've written it as a quadratic. It multiplies to be negative 30 and adds up to be negative 1. 6 times 5, negative 6. Then we'd have to long factor because our leading coefficient's 2. So we drop 2u squared, drop down negative 15, and break. So that middle term becomes negative 6u plus 5u, factoring by grouping. Pulling out the greatest thing in common here is 2u, so then left is u minus 3. Pulling out the greatest thing in common here is a positive 5, so then left is u minus 3. So now we'll pull out u minus 3, leaving me with 2u plus 5, because it divides out. Then you'd say, but it's not u. U is x squared. So we have x squared minus 3, and then 2x squared plus 5. And now we're done, as long as the quadratic does not factor. So let's check. What multiplies to be negative 3 and adds up to be 0? Nothing. So that part doesn't factor more. What multiplies to be 10 and adds up to be 0? Nothing. So we're done. Are we okay with the U-substitution? Another one or not? Well, actually, we are going to do this one. Okay. This is a U-substitution. It says factor 3x minus 3 squared plus 11x minus 3 minus 4. People go crazy and they start multiplying this out. If you're factoring, you're not going to want to multiply things together. Factoring, you never want to start multiplying stuff together. Ever. So you'd say, okay, now look, we've seen one like this. Looking at this, isn't there 2 terms? What's in common here? So this one's the greatest common factor problem down here. So pull out, so divide by x minus 3, divide by x minus 3. So then left would be 3, x minus 3, and plus, and then 11. So then we've seen that we would have an x minus 3. We would distribute that in, so we'd have a 3x minus 9 plus 11. So then we would have 3x plus 2. That is not the same. That's why I said not to be mistaken with up here. Now they look similar, but here's the problem. There's 3 terms. They don't have a greatest common factor because it has to be in all of them. Now it is quadratic in form. Does everybody see what U-substitution could be made if we wanted to make our lives easier? Because look, it's degree 2, degree 1 constant. That's quadratic in form. So what would our U substitution be? U is equal to what? X minus 3. Now replace your X minus 3's with U's. So we have 3 U squared plus 11U minus 4. Then you factor out what multiplies to be negative 4, adds up to be not negative 4. What multiplies to be what? Negative 12. So what multiplies to be negative 12 and adds up to be positive 11. 1 times 12, it looks like negative 1. Negative 1 plus 12. We're going to long factor, so we drop and break. Drop, and break. So 3U squared minus 4. Break down the middle term as these two things. So that was minus 1. So minus 1U plus 12U's, factoring by grouping, pulling out a U. So divide by U, divide by U. Left is 3U minus 1. Pull out a positive 4. Then divide by 4, divide by 4. Left is 3U minus 1. So pull out 3U minus 1. And left is U plus 4. I erased it, but we had U is equal to X minus 3. So now we need to replace that. With this one, we will have to be a little more careful than the other one. So we have 3 times all of U. U is that, so we need parentheses. So we have a big parenthesis, and we have a 3 times X minus 3. Then we still have minus 1. Then we have a parenthesis. We have an X minus 3 plus 4. So now let's simplify inside the parentheses on each. So that's 3x minus 9 minus 1. So that becomes 3x minus 10. Then on this one, combine like terms, so that's x plus 1. X plus 1. U substitution. So now we know how to factor with the U substitution because it's quadratic in form. We didn't factor it out, but we made a U substitution of x minus 3. Yes. Because it looks, so that's a great question. Can you see how it looks quadratic? Something x squared, then something x minus 4. So what would make it a quadratic? If this was just an x, and if this was just an x. So does that make sense? So that would be your U substitution. It's just making it prettier to see, so you don't lose focus on what you're doing. So yeah, great question. So right here, degree 4, degree 2, degree, then constant. So once again, if you'll notice, it's actually that middle term. Like you see how Z squared, that's our U substitution. X minus 3 was our U substitution, so it would be that middle thing. So what would be our substitution here? X minus 2. And then when you replace it, if it really looks pretty, you've done it right. Okay, cool. All right, that is the end of the lessons for today. So you do have about 20 minutes. Go for it.